Welcome everyone. Today we move on to the next topic in the subject Environmental Engineering 1, Module 4. This module mainly deals with the filtration process in water treatment. So in the previous class we discussed what is a slow sand filter. So in today's class we are going to discuss what is a rapid sand filter. We are going to discuss the rapid sand filter gravity type. So we know that a slow sand filter is called so because it has a very low filtration rate, and also we saw that in the case of a slow sand filter it requires a large area for construction of a slow sand filter, and a rapid sand filter actually can be differentiated from a slow sand filter in various aspects. Firstly, the effective size and the uniformity coefficient of the filter media that is being used. Then the rate of filtration. So we know that in slow sand the rate of filtration is very slow or low, and in the rapid sand it is high. So again, rate of filtration and the filtration head, then the method of cleaning the filter, and also the frequency of cleaning. Also, we discussed that in the case of a slow sand filter, the pre-treatment process, that is just before the filtration through a slow sand filter, the pre-treatment is plain sedimentation, that is no coagulant is added. Whereas in the case of a rapid sand filter, before the filtration process, the pre-treatment includes the process of sedimentation with coagulations. So some chemical coagulants will be added, and then this sedimentation with coagulation will be effected, and the flocks will be formed and settled, and then the clear water is sent for filtration in the rapid sand filter. Now the rapid sand filters are again divided into two parts or two types. One is the pressure type and the gravity type. So in the case of a gravity type sand filter, the filter medium that is used it is coarser than that which is used in a slow sand filter. And in the pressure type rapid filter, here actually the water is allowed to filter through pressure, or it is allowed to filter under the pressure in the case of a pressure filter. And also the rapid sand gravity filters, that is the gravity type rapid sand filters, are most commonly used in the water supply projects. Now moving on to the various parts of a rapid sand filter. So like the slow sand filter, a rapid sand filter also it also consists of the following parts. That is, it consists of an enclosure tank. There is a filter media. Here also we use mostly sand as a filter media. Then the base material, that is gravel, and we have an underground or under drainage system and the various appurtenances. So we'll see each of these. So coming to the enclosure tank, so in this case, that is in the case of a rapid sand filter, it consists of enclosure tank which is usually smaller in size, and hence it is placed under a roof, and the tank is generally rectangular in plan, and it is constructed either in using stones or bricks or even concrete. So if it is constructed using concrete, what we do is normally we coat it with a waterproof material so that the water is retained in the tank. And here again, the depth of the tank varies between 2.5 to 3.5 meters, and each unit will have a surface area between 20 to 50 meters square, and usually they are arranged in series, and the length to width ratio is kept between 1.25 to 1.35. And in addition to the under drainage system, the tanks will also have like I said, here you can see in this figure, here at the bottom you can see the lateral drains. So they are called as the lateral drains, so we'll discuss that later. So in addition to the under drainage system, it will contain you can see here the lateral drains, and at the top you can see the wash water troughs. So these are called as a wash water troughs. So that will be spanning across the length or across the width of uh, the tank, and this is mainly to distribute water to be filtered during the normal operation, and also it collects the wash water during the cleaning process. So after the after considerable filtration is effected, what happens is the sand bed or the filter media will be clogged with particles. So we will have to wash this or clean this. So for this we will have water being passed into the filter media through the lateral drains at the bottom, and then this will wash the sand or the filter media and remove all the particles that are clogged. So this process we call it as backwashing. So backwashing we will discuss in the next class. So here you can see, as you see here, there are the wash water troughs at the top through which the water that has to be filtered, or the water that is a wash water after washing the filter media, it is being transported through this wash water trough. So these are the additional parts of a rapid sand gravity filter. Now coming to the next type or the next part, that is a filter media. So here again, like in the case of a slow sand filter, we use sand as a filter media. So the sand that is used, it should have some properties, like it should be clean from any organic matter or other debris, or there should be no suspended matter, and it should also be very hard and it should be resistant. And the size of the sand that is used is normally you can see here the effective size, it should be between 0.35 to 0.6 millimeters. The common value is normally 0.45, and the uniformity coefficient is between 1.2 to 1.7. So that is the uniformity coefficient that is preferred. Common values normally 1.5. So coming to the sand bed. So the sand bed is it should be such that the flock should not break through the sand bed, and also the depth of the sand bed is usually between 60 to 90 centimeters. And next is a base material, that is the gravel over which the filter material, that is sand, is supported. So the filter sand is actually supported on the base material, and this mainly consists of graded gravel layers. Here you can see, as given in the table, it is all in the depths, equal depths, that is 15 centimeters, and also the size of the gravel in the topmost will be lesser than that compared to the bottommost layer. So this is how the base material is chosen. Now coming to the under drainage system. So the under drainage system, it has mainly two functions. Firstly, it will collect the filtered water over the area of the gravel bed, and secondly, it provides a uniform distribution of backwash water without disturbing or without upsetting the gravel bed and the filter media. So this is the main purpose of a under drainage system. So it collects the water that is being filtered through the filter media, and it goes on to the next process in water treatment. It will be transported to the next process through the outlet. And then one more purpose what it serves is, it provides a uniform distribution of the backwash water. So I told you, as the filter material is getting clogged, when you filter sufficient quantity of water, it is necessary for us to clean this filter media so that it can effectively filter the water. So this process of cleaning the filter media by using water, we call it as backwashing. So this underground or under drainage system actually provides the or distributes the backwash water, and this is also done without disturbing the gravel bed or the sand filter media. So this is about the under drainage system. So here in this figure you can see it is a figure which shows a rapid sand filter having an under drainage system. You can see the pipes, they are all perforated laterals that are provided at the bottom of the tank, and then you can see here in this figure the coarse aggregate, that is a gravel, the sand media, and of course you can see here the wash troughs that is placed across the length or across the width normally, and this is mainly to admit or to supply water to the filter to the tank so that it can be filtered. So this is a typical layout of a rapid sand filter. Uh, Again here you can see that there is a under drainage system that is provided. So these are the various parts. It consists of the wash trough. You have the filter media here, and there is a cast iron manifold here at the center, the central pipe. Then you have the floor here, the perforated laterals, again the graded gravels, etc. So these are the various parts of a rapid sand filter. This is a cross section of an under drainage system. You can see there is a lateral drain and there is a strainer also. A strainer means to strain the waste. So this figure shows the pipe and the strainer. So this is a system here. Actually in the system the laterals are provided, mainly the strainers are provided because they are usually used to strain the water, and you can see it also distributes the wash water without any jet action. And next comes the appurtenances. So appurtenances, there are additional fittings that are provided, and the following appurtenances are normally used in the case of a rapid sand gravity filter. Firstly, the wash water troughs, then we have the air compressors and the rate control device. So a wash water trough, like we saw in the figure here, you can see here there is a wash water trough. Here you can see this wash water trough. So wash water troughs are actually provided at the top of the filter. It's mainly to collect the backwash water after it emerges from the sand. So the sand will be cleaned, and once the water is out, it will be collected through the wash water trough. So this is a typical wash water trough that is shown here. Then coming to the next, that is a air compressor. So air compressors are actually used to supply air for agitating the sand grains during the washing of the filters. So again, this is during the backwashing process, the sand has to be agitated so that the particles that are held between the sand particles are removed. So air compressors are actually used to supply air for effecting the process of agitating the sand during the washing of the filters. Now coming to the rate control devices. So for each filter unit, the flow of the influent, the effluent and the wash water supply and the wash water waste must be controlled by using some devices. So this is so we have to maintain a constant rate of filtration, which is very much needed. So in that case, in order to control this, we use the rate control devices. So these are the various these figures just shows the arrangement of the wash water troughs, and also you can see the plan and the sectional view of the wash water troughs. So in the next class we will be discussing in detail the working of a rapid sand filter, as well as comparison between a slow sand and a rapid sand filter, and after that we will be going to the design aspects of the both types of filters. So that's all for today. Thank you.